Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. On behalf of University Technology Malaysia, I would like to welcome all viewers to the 105th Professorial Inaugural Lecture Series that will be delivered by our respected speaker, Professor Engineer Dr. Sevia Mahdaliza binti Idrus Sutan Nameh from School of Electrical Engineering, Faculty of Engineering, UTM. The title of today's lecture is Radio over Fiber Technology from Research to Airport Operation. I'm Nadia Huda Zulkifli, your MC for today's program, who is also from the School of Electrical Engineering. First and foremost, we thank Allah, the Almighty, for this opportunity, and let's begin with Surah Al-Fatiha as we seek for His rahmah and blessings to our program that all of us will get benefits from it. Inshallah. Al-Fatiha. Alhamdulillahirrahmanirrahim. Maliki yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Shiratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim. Amin. Bismillah. Next, to mark the opening of today's Professorial Inaugural Lecture Series, I would like to invite the Honorable Chairman, Dato' Professor Emeritus Dr. Ahmad bin Darus, the former Dean of SKE, to give his opening remarks and bio-sketch recital of our speaker. Over to you, Dato'.
Assalamualaikum warahmatullahi wabarakatuh. Terima kasih Profesor Madia Dr. Nadia Huda Zulkifli, pengurusi majlis. Yang diraihkan Profesor Insinyur Dr. Sevia Mahdaliza binti Idrus Sutan Nameh yang akan memberi syarahan petang yang mulia ini. Yang berbahagia Profesor Insinyur Dr. Abu Samah bin Muhammad Safaat, pengurusi Innovative Engineering Research Alliance, serta hadirin hadirat di dalam Dewan dan yang hadir secara maya. Syukur Alhamdulillah, saya merasa bangga dapat bersama sebagai pengurusi syarahan perdana Profesor Insinyur Dr. Sevia Mahdaliza binti Idrus Sultan Nameh. Beliau yang saya kenali sejak 1997 sebagai pelajar seliaan saya untuk tesis sarjana beliau. Selanjutnya menjadi pensyarah di Fakulti Kejuruteraan Elektrik sejak 1999 hinggalah ke jawatan sekarang seorang profesor. Saya ingin berkongsi biodata beliau dalam bahasa Inggeris untuk makluman semua. Profesor Insinyur Dr. Sevia Mahdaliza Idrus is the Deputy Dean, Development and Alumni, Faculty of Engineering, University Technology Malaysia. She received her bachelor degree in electrical engineering in 1998 and master in engineering management in 1999, both from UTM. She obtained her doctorate degree in 2004 from the University of Warwick, United Kingdom, in optical communication engineering. She has served UTM since 1998 as an academic and administrative staff. Her main research interests are optical communication system and networks, optoelectronic design, and engineering management. Her research output has been translated into a number of publications, H-Index 15, and IPR, including a high-end reference book, Optical Wireless Communication, IR Connectivity, published by Taylor and Francis. She has 49 book chapters and monographs, over 200 refereed research papers, 8 patents granted, 36 patent filings, and holds 31 UTM copyrights. To date, she has secured and been involved in 84 research and consultation projects with a total value of 115.6 million. Professor Sevia is a senior member of IEEE and a member of the editorial board of few refereed international journals. She has been appointed as guest professor at Osaka Prefecture University and Tokai University, Japan in 2011 and 2014 respectively. She is the founder and director of UTN spin-off company, Ismat Urus Sendian Berhad, which successfully commercialized her invention, which is a novel airtime-based mobile micropayment solution and application-centric IoT-based mobile enforcement device for smart city. She is actively involved in a number of industrial and international research collaboration projects, delivered keynote and invited speakers to many international conferences and seminars. Based on her active contribution with industry for smart city solution, she has been awarded the 51 Most Impactful Smart City Leaders 2019 Award in conjunction with World CSR Day and World Sustainability Congress 2019 in Mumbai, India on March 2019. She led a 4-year G2G project on radar over fiber for range object debris detection system, field trial at Kuala Lumpur International Airport, a collaboration project between UTM, Hitachi Kokusai Electric Japan, and Malaysia Airport Sepang, under financial support from the Ministry of Internal Affairs and Communication, Japan. The radar over fiber foreign object detection system field trial at KL has been very successfully demonstrated to the Ministry of Internal Affairs and Communication of Japan just 2 days ago, following its 4 years of rigorous research. This is a great occasion that Professor Sevia will be sharing her precious experience and knowledge in managing complex projects as this. I believe the academics and students as well of UTM can benefit from her wide experience in commercializing research output. Her enterprising qualities and perseverance in running research output to the real world, the industry, and the community at large. I would like to congratulate Professor Dr. Sevia on her remarkable career and wish all the success for all her future undertakings. I believe with her age, there is a lot more that she can contribute in realizing the very reason for the establishment of this university. I'm looking forward to listen to the lecture by Professor Sevia. Thank you very much.
Alhamdulillah. Thank you, Dato' Ahmad Darus, for the very insightful opening and impressive biodata. Okay, now, without further ado, let's have Prof. Sevia to deliver the Professorial Inaugural Lecture. Okay, over to you, Prof.
Bismillahirrahmanirrahim. Assalamualaikum and good afternoon. Thank you, dear MC of the day, my sahabat, Associate Professor Engineer Dr. Nadiatul Huda, Honorable Inaugural Lecture Chairman, Professor Emeritus Datuk Dr. Ahmad Darus, respectful commentator of my lecture today, my Sifu, Professor Engineer Dr. Abu Samah Muhammad Sufaat, my respectful Dean, Professor Dato' Rafiq, thank you for being with us today. I feel honored to be invited to deliver a speech at this public lecture. First of all, I would like to thank the organizer, Faculty of Engineering and Office of Deputy Vice Chancellor, Academic and International, University Technology Malaysia, It is a great pleasure to be present here with all of you here at the hall and virtually wherever you are, especially to all my family members, friends and collaborators who involve and supporting my academic and research work. Thank you again, Alhamdulillah, syukur. Today, I would like to talk and share about radio over fiber technology and its application. Inshallah, not so technical, more on experience sharing as Dato' Ahmad mentioned just now, on a successful quadrupolic Helix International Malaysia-Japan collaborative project on high precision foreign object debris detection system from research to airport operation at Kuala Lumpur International Airport. To begin my talk, allow me to introduce my dear family, strong pillar of my life, my lovely husband Syafizal, ibu saya Murni, anak-anak yang dikasihi Syafi'i, Syafinas, Syafira, Syafini yang berada di rumah, abang-abang, kakak, adik, sanak saudara di Kuala Lumpur, di Kedah, di Padang Pariaman, Indonesia, sahabat andai di mana sahaja berada. Alhamdulillah, syukur dengan kasih sayang selama ini. Moga kita sentiasa dilimpahi rahmat dan rahman Allah Subhanahu Wa Taala. Thank you very much, Dato' Ahmad Darus, for sharing my biography just now. However, allow me to share a little bit about my academic journey. Saya adalah murid Sekolah Rendah Kebangsaan Sungai Penchala. Tuan-tuan tahu Sungai Penchala di mana? Di pinggir Kuala Lumpur. Sekolah Menengah Taman Tun Dr. Ismail and Victoria Institution Kuala Lumpur. Apa khabar semua, rakan-rakan, kawan-kawan SKSP, SMTTDI dan juga Victoria Institution, jasa semua guru-guru daripada ketiga-tiga sekolah ini hanya Allah sahaja yang dapat membalasnya. Seterusnya saya menyambung belajar di UTM. I am alumni for UTM, bachelor degree and master degree, supervised by Professor Engineer Abu Samah and Dato' Ahmad for my final year project and master. Professor Abu Samah is my sifu. He is my academic advisor. He's not just be my advisor during my study until now as a colleague in UTM. Syukur Alhamdulillah, glad both of you are here. Sihat walafiat. Thank you for your guidance since student until now. Alhamdulillah. Then I continue my study at Warwick, 1999 actually, until 2004, under supervision of Professor Emeritus Roger J. Green on radio over fiber, which my focus on radio over wireless optical link. Thank you, sir. I believe you are there in England. So happy he's still healthy and cheerful in England. We regularly keep in touch via IG, WhatsApp and also Facebook. I messaged him early morning today. And during my study, my senior next to me there, Dr. Ramirez Inigas, sharing knowledge on optical communication. We work together. He's now with Glasgow University. I was graduate from PhD in 2004, Viva at Oxford University in November 2004. During that time, examination are conducted at the external office at the Oxford. Thank you, Professor David Edwards of Oxford University, my external, as well as Dr. Mark Leeson of Warwick University, my internal. Then after that, all is history. I keep growing, learning, sharing my knowledge in this field. This is my graphical showcase of 17 years of my contribution to UTM, industry and society. This is our task as a lecturer, accommodation, responsibility which not only on teaching or academic administration, we always need to continue learning, exploring new knowledge, then contributed back to society and stakeholders, national and globally. I show here in terms of what we usually, as a lecturer, we need to contribute in terms of postgraduate supervision, research, consultation, publication, innovation work, industry and community engagement, and many more. I really like to mention here, thank you very much, all my colleagues, as well as my students, 18 PhD already graduated, and also 10 of master's degree. I know you are there. Hopefully you are with me today. My postdoc, and also 13 PhD ongoing and also masters. Please support me, guide me, insyaAllah, jika umur panjang. I wish to can continue contribute through UTM for the next 13 years before fully retired, insyaAllah. My research is anything related to photonics and communication engineering, but my focus are optical wireless communication. This one of our early book published by Pearson, Principle of Communication, co-authored with Professor Abu Samah and also Dr. Nadiatul Huda and a few more colleagues from School of Electrical Engineering. Fiber optic communication system, and this is another book published with Dr. Roberto Ramirez Eniguez and also Dr. Ziran San, published by CRC Press, Tyler Francis. And now my recent works is radio over fiber, focus on wired wireless converged radio access network for massive IoT traffic. If anyone you out there looking for a PhD, please contact me. There is a grant for you waiting at UTM. This is the project, WDM limited wave radio over fiber wireless for high-speed rail communication. The case study are Malaysian high-speed rail condition. Photonics in communication, expanding and scaling. We can do research. My interest in long haul, metropolitan. It can be home access or specific to the device, both interchip and intrachip. And also photonics technology diffusing into other application sector. Health, biophotonics, environment sensing, security imaging. And of course now, that's a little woman in the photo, me with the aeroplane, aircraft A380, working on radio fiber for runway surveillance, which is this project. Radar over fiber from research to airport operation. The actual title for this project is the High Precision for Foreign Object Debris Detection System Field Trial at Kuala Lumpur International Airport. The FODS project is multilateral collaborative effort between Malaysia Airport, Hitachi and UTM. This is one of the huge quadruple helix international academia, industry, government and aviation community collaboration between Malaysia and Japan, including the regulator from Japan is Japan Civil Aviation Bureau, and from Malaysia, Civil Aviation Malaysia. And also the regulator for the spectrum, MCMC. Thank you very much. And thank you very much for Japan Embassy for your engagement. And of course, goes to the funder, Ministry of Internal Affairs, Communication of Japan, and also KKMM for your support. The FODS technology is one of the initiatives to enhance the aviation sector. We are in Malaysia very grateful that Malaysia has been chosen as the location for this field trial high precision field object debris detection system at runway 2 Kuala Lumpur International Airport. We believe from this project, we can enhance the safety and surveillance measure of the runway. KLIA, we are proud to test the first radar at 90 gigahertz frequency range in Malaysia. From this, it gives a huge contribution to I2R standard. And this is the key collaborators for the field trial. First, the industry partners, Malaysia Airport Sepang Sdn Bhd, Hitachi Kokusai Electrics, Asmat Urus Sdn Bhd, UTM spin-off company. And the research and partners, UTM, University of Technology Malaysia, National Institute of Information Communication Technology of Japan, Waseda University, Electronic Navigation Research Institute, Japan, and RI. Thank you, Japan. Thank you very much giving us opportunity. Allow me to share with you how we embark to this project. And I hope this one can be reference to all my colleagues out there. Any opportunity that we work with the international body, please follow and keep working and deliver your work. And inshallah, at the end of the tunnel, there is a big opportunity waiting for you. This happened start from the recognition and collaboration with Japan back in 2009 as a visiting researcher at Sign and Contact at NTT Makuhari, Tokyo for ROF project with TM R&D. I went there with my Sifu, Professor Engineer Dr. Abu Bakar, and also my students from TM R&D. And then follow, I've been invited to Osaka Prefecture University, hosted by Professor Yutaka Katsuyama as a visiting professor from October to November 2011. Thank you very much to my colleague, Dr. Raja Zahila, for the arrangement and hosting me there. And then next, again, in 2014, with my relationship with the colleague, Sifu in this area, Professor Osamu Mikami, I was invited as a visiting professor at Tokai University on October 2014. Alhamdulillah. And through him, I get in touch with the entity again, Science Core Technology at Sugi, Tokyo, for RF device fabrication in October 2014 for one of my PhD student works. And this is the thing, recognition and collaboration with Japan, how we start this journey with the great involvement of NICT, National Institute Information Communication Technology, UTM signing the MOU. In this photo, our former VC, Datuk Wahid, and President of NICT exchanging UTM and NICT MOU in conjunction with the first Asian IVO NICT meeting at Bangkok in 26 February 2015, witnessed by Professor Abu Sahmah. Then through that effort, we work on the research project funded by NICT. I believe this kind of research now ongoing very active, funded by NICT. One of it is this one, 3 years Asian IVO project from 2016 to 2019, short distance communication and imaging for application in Asian region. But membership from Vietnam, Malaysia, Thailand, Indonesia, and Japan. And through that, together with my research collaborator from NICT, Dr. Kano, and also Professor Kawanishi of Waseda University, we embarked the journey to bring the idea and the technology to Malaysia to do a site visit on March 2017 at the Kuala Lumpur International Airport with the assistance of Civil Aviation Malaysia and also Malaysia Airport Holdings Berhad. And through few more meetings in May 2017 in Bangkok, organized by MIC Japan. Thank you again, MIC Japan. During the executive workshop, a proposal to conduct field trial for the ROF FODS in KLIA was discussed and presented. Along with me is Senior Manager of Malaysia Airport, Mr. Wahab, as well as Mr. Ehsan, came along on this discussion and proposal presentation. And then on the second visit, there is a first technical meeting at Kuala Lumpur International Airport, attended by Hitachi Kokusai, Waseda University, ENRI, NICT, and UTM. Then with the numbers of effort from everyone from the team, thank you very much. MOC signing on the 10th January 2018 between Malaysia Airport, UTM, Hitachi, with the effort of MIC Japan, attended by key organizations both from Japan and Malaysia, and a number of airlines operator at KLIA. The event has gained huge worldwide media coverage, and KLIA now is a focal point for the new technology field trial. Okay, allow me to talk about a little bit detail about this project. It's related to aviation industry, a key infrastructure and growing demand. And of course, not the aircraft need the safety, runway safety is vital. Okay, the focus is about this tiny thing in runway. We need to avoid this and we need to clean this from every time. FOD is defined by ICAO, any object located in an appropriate location in the airport environment that has the capacity to injure airport or airlines personnel and damage aircraft. We need a method to remove this 24 hours, 7 days a week, the whole year round. Let me recall you tragedy by FOD on the runway in France, the crash of Concorde, Air France Flight 4590 at Charles de Gaulle Airport near Paris in 25 July 2000. It was caused by FOD, tiny titanium alloy just a size of 2.5 centimeter width and length 42 centimeter. It's actually is a thrust reverser that have fallen from the Continental aircraft during takeoff about 4 minutes earlier. All 100 passengers and 9 crew on board the flight, as well as 4 people on the ground were killed. This strategy not just vanished the aircraft, also closed the business of Concorde. There is no Concorde anymore. It's a history. It's a bad history. Safety and operation of busy airport require regular inspection. Is conducted 4 times a day as required by ICAO. Additionally, temporary runway closure by accidents occurs many times. This is statistic of runway closure in Tokyo International Airport in April to December 2015. So there is numbers of debris and the huge this closure raised inefficient operation of the runway is the cost to the airport operator. Improvement of FOD inspection after accident is one of the key issues for efficient airport operation as well. I would like to share with everyone here is a public data comparison among busy airport, international airport. If you can see this report by the ACI Annual World Airport Traffic Report in 2015. The cost, the estimated direct cost of FOD and also estimated total cost. For example, for the Kuala Lumpur International Airport at number 39 in the world, it costs KLIA about 1.8 million USD per year, as well as 2.2 million per year. So we need a technology to reduce this cost. One of the technology available system needs is a laser or optical imaging. This is something like camera. Camera can focus on the FOD and then inform the airport operator. So, however, we need detection system for small metallic FOD. The system needs to have a capability to detect tiny object, display the situation of runways, 24 hours, 365 days a week, a year. Many restrictions for construction and setup. In general, through our study, imaging and sensing system with both high resolution, wide coverage cannot be realized by optical technology alone. It requires radar and at much higher frequency at millimeter wave region. Okay, because we need to ensure this runway, this is the KLIA runway 2, to be clear from FOD. Okay, what is the radar? Allow me to share with you some basic understanding about radar. Radar is radio detection and ranging. Radar is a system that use radio wave to determine the range, angle, or velocity of object. To detect aircraft shape, spacecraft, guided missile, motor vehicle, weather formation, and terrain. So the radar transmitter producing electromagnetic wave in the radio or microwave domain, and a receiver processor to determine the properties of the object. There is a huge numbers of application of radar. If you can see here in this photo, marine radar antenna for the marine application, and also airport civilian radar. Okay, do you have radar at your home? Please. Okay, just ask you, can you spot a marine radar above me there? This is my photo at my one of my project site in Petronas, Melaka. Okay, you can see clearly there is a radar above me. All right, a little bit again about FOD radar theory. The radar works with the radar cross-section value, which is through the electromagnetic wave, it can detect the size of the object and report and through the special signal processing. If you look at the UTM Lively Asia aircraft, there is a big aircraft. If detected by radar, the reading will be something like about 20 dBSM. For the small aircraft, it's about 10 dBSM. And for the vehicle, it's smaller. And human body, something like about negative 10 dBSM. And then metallic cylinder, about 1 inch, about 20 dBSM, negative 20 dBSM. And bird is kind of FOD. It's about 35, negative 35 dBSM. So the smaller the size of the object, the shorter the wavelength and the higher the frequency should be. So this is the range of hazardous object for runway operation. It's require about 90 to 100 gigahertz radar. Okay, just a little bit understanding how is it this electromagnetic spectrum works. If you look at here, the source for AM radio, for microwave oven and so on. The size for the AM radio, the radio that we listen every day, FM radio and so on, the length is about the size of building. But for the radar and also microwave, it will be size like butterfly, needle point and so on. At a certain spectrum is non-ionizing, which is safe, with a certain high of power, level power. And also for the next spectrum, after the visible and ultraviolet, there is ionizing spectrum, which is soft X-ray, hard X-ray, and also radioactive element, which is dangerous, but it's really useful with a proper design system for many applications. Okay, just to give some understanding what is the radar and where we works actually. For the maritime radio and navigation, very low frequency and low frequency maritime radio navigation, it's about the wavelength about 1 kilometer. The frequency used up to about 300 kilohertz. AM radio is somewhere about 3 megahertz. And aviation radio. And for there, about 3 gigahertz now, UHF television, our mobile phone, GPS, Wi-Fi, 4G, 6G, and most of 6G now working towards 15 gigahertz to 30 gigahertz. But the FOD radar are working here at the somewhere about 90 to 100 gigahertz. It's really far from those radar available in the airport area. Okay. Excuse me. Okay, this is some comparison of foreign object debris detection system commercially available. First, FOD detect by Excite system, manufactured by Israel. Tazia Kinetic UK, MOOC Tazia. All is working at the Bluetooth region, but for this linear cell radar, Hyde Japan, Hitachi Kokusai, at 90 to 100 gigahertz. And now it's under trial at Narita International Airport in Kuala Lumpur. The needs of high precision FODDS. Okay, the concept, hopefully this diagram can be understood well from everyone, my friend. The radar front end cell are connected back end by fiber. The application, first, it will detect, radar will detect, camera will confirm, and then alert through the system to the SI staff and dispatch and remove and report back and open the runway. This is the simple algorithm for this system. Just for understanding for our day-to-day about radio fiber, every one of you here are connected through fiber. When you looking at this Facebook, when you watching this talk through YouTube, definitely back end you are connected through fiber around the globe. So this is the example of radio fiber application, mobile base station antenna, connecting a mountain valley using optical fiber for tall building and also subway metro. All right, what is the RF linear cell radar? RF system consisting of many antenna units, remote antenna units, linearly collocated along with optical fiber to form linear shaped cell. If you look at here, there is a data center connected through fiber joint signal processing. There is a sensor head, the radar will be radiated and detect the object. In terms of layout, this is for your understanding how is it works. Radio fiber back end and the millimeter wave radar at the front end, detecting the foreign object debris. It will send data to the control center and alert the pilot either takeoff or landing to make sure the runway are clear before their landing. Okay, since 2017, there is a field trial in Narita International Airport conducted at the runway 34R there is a prototype of FODS, Singapore, and the central processing unit at NIA buildings. And later, with the improvement of design and system, it goes to the Malaysia. This is timeline of FODS Japan Malaysia Joint Field Trial. It's 4 years project, and Alhamdulillah, inshallah, will be continue another 2 years after next Japan fiscal year. Thank you, MIC. This start with the fundamental study and experiment 1 and field trial planning, system design for KLIA, fabrication of prototype. Allow me to share the milestone achieved. First, improve engineering design and construction plan for the FODS KLIA. We got a radar configuration and optical networks completion. And then along the field trial experiment 2 and 3, infrastructure and 1 prototype ROU system are completed. We continue with the field trial phase 1. Now is field trial phase 1. And then next will be field trial phase 2. And this is the summary of our activity at KLIA. And thank you for Japan team. Despite COVID-19 pandemic as well as Malaysian movement control order, you are coming here to complete the project together with the Malaysian team. Thank you very much. Okay, we conduct experiment 1 and 2. Now we almost completed field trial phase 1. Allow me to share with friend here the experiment and development phase. Hopefully you will confident with this system. You will confident with KLIA. First, FODS experiment, KLIA system fundamental design, land survey cross-section measurement. We do the pole structure construction, E&E in fiber network installation, system installation and configuration, FODS experiment 2 and 3. And this photo here is the prototype, which is about 6 months in KLIA, then later reinstall again with a new one. First experiment is conducted on February 2018 at UTM campus and also KLIA. It's a demonstration of single RU radar over fiber and propagation study. We conduct at UTM Kuala Lumpur campus on February 2018 at the courtyard in MJIT. Thank you very much for the commitment of the UTM KL campus, and thank you to all colleagues in KL. You allowed to clear the parking area around during the experiment. Okay, and Alhamdulillah, we received the AA license. Thank you MCMC. On February until 15 of 2018, and for everyone, this is the first time, the highest frequency radiated in Malaysian land. Alhamdulillah, it's a history in our area, licensed by MCMC. Okay, next year, demonstration of single RU radar over fiber propagation study at the KLIA LCCT apron. To test the system at the real airport environment. This is the radar, and we conduct a few experiments just to give you understanding about the radar. You can see our researcher there, Dr. Rashidi and Dr. Farabi, walking, leaving the radar. You can see their signal there. Big signal are moving. All right. And this is how the radar detect, and this is to confirm to you, the radar is safe to human body. And then Dr. Kano from NICT are walking towards them. You can see huge signal of Dr. Kano walking towards Dr. Rashidi and Dr. Farabi. All right, this is how the radar detect, give the information to the system, and then later camera will confirm the existence of FOD at the runway. All right. All right, next, we do the survey drawing FOD field trial site. Thank you to Bumi Solution as well as the Hafizi Juruko. Do the land survey and cross-section survey for KLIA runway 2, 14 right and 32 left. This is the site area, KLIA 2, KLIA 1, runway 2, sorry. Okay. And we get approval for our drawing. Because all the design and so on are according to IKO Annex 14. We follow all the requirement and get approval from Civil Aviation Malaysia somewhere in January 2019. All right. And then FODS layout at Kuala Lumpur, this is the layout for your understanding. You can visit the site. If you be at the somewhere in the Anjung Tinjau, you can see the tower. There is supposedly in our proposal 12 tower of radar. And during that phase trial, we conduct for the RAU23. This is some photo of a huge commitment made by the collaborators, contractors, and also consultant. Three-legged pole construction and optical fiber electrical installation. Thank you very much for the design by Professor Mahmud Tahir of UTM for designing this radar pole, three-legged, and colleague from UTM for all the works. KLIA for DS construction, we work hard day and night for the installation during that time. Radar, HDC, and also control center installation. This is the improvement of pole structure design for KLIA FODDS. In Narita International Airport, it used single pole radar. It suffer from the vibration. So we improve with the three-legged pole KLIA. The first photo, the senior manager of Kuala Lumpur International Airport at the Narita International Airport, and then the next photo is the Mr. Kenichi Kashima of Hitachi Kokusai in Malaysia at KLIA. Okay, this pole is less lateral wind load, reduced vertical and lateral vibration. So the vibration study are conducted by Professor Salman Leong. Okay, the radar spectrum license at 96 gigahertz is issued by MCMC. Sorry, MCMC. This is the photo. This is the certificate license to UTM under research. Some photo to share with you. The control center at the KLIA and also the monitoring center at the AOCC building. Visited by our honorable, back then is Deputy Vice Chancellor, now is our Vice Chancellor, Professor Fauzi Ismail. To ensure the system works according to the design, sorry again, we conduct line of sight experiment. My PhD students are involved on this. And colleague as well, vibration testing, FOD sample testing, system evaluation. This is the FOD simulator at the runway. This one, you can see the FOD at the center line of runway in the middle of night. Okay, then there is a launching ceremony, mark successful Malaysia-Japan collaboration. When everything completed on 29 April 2019. It's marked significant achievement for Malaysia-Japan relationship and received huge media coverage as well. Okay, for the FODDS experiment 2, we conducted from April to November 2019. There is a sum of the outcome I would like to share to everyone. When the radar detect the FOD, there is a PPI image is displayed in the monitoring center, and one of the FOD detected on 28 April, very small, you can see a comparison with my business card. It's just the size of 1 cm. This is the smallest FOD detected can be during that time. Hopefully we can improve more. And there is one key outcome of this trial outcome is the capability of the radar detecting and capturing runway surface condition such as crack, dent, water ponding. Those detected has been rectified by Malaysia Airport. Once we got the report, we will directly relay to the Malaysia Airport team. Okay. Let me share with you some of the real situation for FOD event on 2nd October 2019. When FOD detected on FODDS by camera image and confirmed by PPI image. This is the FOD image. This system is automatic. There is no need human intervention supposedly. But during the experiment, our project manager, Mr. Solah, in the monitoring center reporting to inform duty executive DE and then give detail about FOD. And A-side staff click and pick up FOD on the runway. And because during that time is experiment, we need to call. We also establish a WhatsApp group with the KLIA team. Inform there is a FOD at the runway. And you can see clearly there is a FOD. And there is a video here. Okay, the Oscar, the SI team rushing to the site. All right, collect the FOD, and the camera automatically will zoom in. Will check to see whether the FOD are clear or not. And report back to the deputy executive. The FOD are clear. Okay, this is the way of communication during that time. And white cloth from aircraft are found during this event. So then, through that, we come up with the idea, site safety inspection that allow the communication of the FODDS to the OSCAR site team automatically, real time, when the camera, when the radar measure, assess and calculate, camera direct zoom focus that capture the best image, detected FOD data sent to the user app, which is RC, developed by Asmaul's team for Malaysia Airport. And through that, the airport team can know where the location of FOD, get the actual photos of the FOD, report back once it's already removed. The third experiment is conducted on November 2019, led by Professor Kawanishi, to study on interference caused by reflection from airplane. This is our lab. Our lab is at KLIA, location at the apron of Malaysia Airlines. This is the arrangement to see the effect of the aircraft reflection towards the radar. Okay, it's supported by two postgraduate students from Waseda University, also postgraduate student Miss Fiza from UTM, and my postdoc Dr. Wan Hafiza for this experiment together with the Hitachi Kokusai and also Malaysia Airport team. And during this interference study, Alhamdulillah, thank you very much. There is a courtesy visit by Professor Dato Dr. Ahmad Fauzi, DVC of UTM, together with the General Manager of Hitachi Kokusai Electric, Masaru Adachi. Also present during that time, Dato Dr. Razin, Chief Safety Officer of Malaysia Airlines Berhad, Tuan Haji Arif, Senior General Manager of Malaysia Airport, and project member officers from the Hitachi, UTM, Waseda University, NICT, and Malaysia Airlines. Thank you, Dato. This is the our monitoring center at the KLIA. Okay, the third phase, the second phase for FODDL field trial 1 from December to March 2021. Now the system are ready. The focus here is the one is the technology and knowledge transfer activity, radar performance improvement, mobilization process from Japan to KLIA, because during the experiment the equipment are land to Malaysia and return back to Japan, but now the equipment will be delivered to KLIA and UTM. MCMC inspection for special license, installation and configuration, and also MASPS evaluation. Okay. Despite the project delay due to COVID-19, but we completed within the time with the hard work of our team member. Okay, allow me to share with you some of the technology and knowledge transfer during this activity. Technical visit to NIA and High Itachi factory for 5 Malaysia airport officer. Training in Japan, Mr. Sola and also Dr. Farabi, UTM lecturer. Okay, industrial attachment with Malaysia Airport for this project, Dr. Azura and Dr. Sumaiti of MJIT UTM. Postdoc attachment with the FODDS project, Dr. Wan Hasfiza from UMT. And postgraduate study related to FOD radar, 2 PhD students, Miss Nadia and also Miss Fiza, under our supervision. 2 master potential of MAHB officer soon. All right. Okay. And technology knowledge transfer also involve Malaysia Airport Sepang staff from SI department, ITD and also engineering department and UTM research consultation from ISKE myself Dr. Nadiatul Huda Dr. Nur Hisham and Dr. Farabi, Dr. Jasrul, Dr. Zulkarnain, Dr. Rashidi and Dr. Aniza from civil engineering Professor Mahmud and also Dr. Sheikh Poin Ngan this is his photo during the testing of the radar pole Dr. Azura, Dr. Simiati and from Razak School Dr. Noliza Muhammad we work together. Thank you very much team and also UPM consultation by Associate Professor Engineer Dr. Shamsuri Yaakob. All right, thank you everyone. All right, the second radar performance improvement at 93.1 gigahertz our ISMA Urus engineer Mr. Solah are there. There is a key new feature of this radar 93.1 gigahertz higher sensitivity, improved cooling system, higher throughput digital data transmission and tropical weather approved casing. This is the one of the outcome of the previous experiment. Okay, this mobilization process from Japan to KLIA for permanently install the system at KLIA. Thank you, Japan. And then recently, this January, MMC MC inspection for the apparatus and Simon spectrum license to UTM for this radar. Thank you, Keysight Technologies and also TechMark to support this work. Thank you very much. And at this moment, KLIA FODS field trial, the installation, configuration and also simulation completed for 6 radar pole and also 1 HDC camera at pole 2.3. This is the system, it works now, ready for operation. Okay, to ensure the system works well and we have to conduct the evaluation according to the proper methodology. We follow minimum aviation system performance specification MASPS for foreign object debris detection by the EuroKE ED235. This document we referred and for this exercise we use 54 types of FOD. Along the way, this exercise also involve useful for our students' PhD research works. Okay, this is the KLIA evaluation area, the runway 2. All right. A little bit technical. This is how the methodology. You need to put the measurement area at area 1 and area 2. Alhamdulillah, Malaysia Airport participate and close the runway. Definitely, the runway must be inactive for during this experiment. We conduct at night most of the time. Okay, FODS KLIA measurement. If you can see here, we need to put 9 FOD, identical FOD at the 2 area, and we need to turn 12 position and radar will collect, and we need to analyze the result and the data to confirm the system performance. Okay, this is the list of 52 FOD for this experiment, field trial, sorry. Okay, this is some of the sample aerodrome and infrastructure provided by Malaysia Airport. Loose asphalt, concrete chunk, light fitting and so on. Okay, we also test the FOD1 wildlife cat during our experiment. The cat measured at -35 and of course wildlife is the most one of the dangerous FOD at the runway. We also test using bird carcass and so on. And we also test for the ability of the FOD-DS to detect ice block, the cross value over the time. This the ice we measured just to show to dear friend to understand about the process. This is our measurement during daytime. There is a day closure at the airport. FOD will be placed for the measurement area there by Malaysia Airport team, Mr. Daniel. FOD will left about 5 minutes to obtain detection probability, and will take about 36 seconds to detect the FOD at the same place. This one is actually aircraft cover, and you can see The result, this one is the PPI image, the line graph, the measurement of the RCS value, and then the photo taken by the HDC. The photo will be delivered to the SITE team apps for them to see what the FOD detected by the radar and also captured by the camera. Okay, these all the example of the FOD evaluation experiment. From first, there is hammer, wrench, light fitting, AGL light, metal cylinder. The above photos are taken by our own camera, my camera, and also the below one is the photo taken by the high definition camera, which is located about 200 meter from the runway center line. And so on, rubber, fuel cap, and so on. We need to repeat the experiment for the whole 52 FOD, type of FOD. Thank you very much, team. Malaysia Airport, Hitachi Kokusai, UTM, also Isma Urus. The above photo is usually we take photo. This is our camera. Above, the lower one is taken by our team who control at the control center from the HDC. We make sure any FOD that we conduct for the experiment, we will look at, we will check and collect before end of the experiment. Alhamdulillah, everyone. Last week, or last 2 days, on Friday, 26 February 2021, we conduct a project progress meeting and demonstration to MIC Japan, witnessed by first and second Secretary Japan Embassy, JCAP Japan, ENRI Japan, UTM Vice Chancellor Representative Professor Safian, Senior General Manager Haji Arif, Malaysia Airport, Division Secretary of KKMM, Head Division of MCMC, Civil Aviation Representative. Alhamdulillah, everything went well. All the hard work of the members of Hitachi Kokusai, Malaysia Airport, UTM, also Isma Urus, done, complete. Despite pandemic COVID-19, the installation configuration completed as planned. Inshallah, everyone, the 6 radar operating well to ensure runway safety at KLIA. Okay, this is the proposal just to give you some idea. For the runway 2 and the runway 3 of KLIA, they only needs about 6 radar units for this application. Usually, this is the thing that we need to work. So why we need to do experiment, why we need to do project, why we need to work so hard, because we need to contribute back to the society. We need to contribute back to the nation and also to the global. This is one of the key outcome of this project, contribution of Malaysia to the International Telecommunication Union Radio Communication Sector, Group Meeting 2019, 2020, 2021, under Working Party WP5B1, we propose revision to working document towards a preliminary draft new report ITUR, technical and operational characteristics of foreign object debris detection system operating in 92 to 100 GHz frequency band. Thank you very much, KKMM, for your trust, for your confidence to send me there to represent Malaysia. Thank you very much. And then this is some of the joint publication between UTM, Hitachi Kokusai, NICT, ENRI, and Waseda University. Few research paper, but the key one that I would like to share here is contribution of Malaysia again to the IKO, Foreign Object Debris Detection System, FODDS, at Kuala Lumpur International Airport. All right, this is the impact and benefit of this project. Allow me to share and wrap up again. This is an example of Japan-Malaysia collaboration, high-end Japan technology transfer to Malaysia. It's the first radar in Malaysia at 90 GHz frequency range in Malaysia, enhanced innovativeness and technology advancement. It's a credible Helix International Academia, Industry, Government, Aviation Committee strategic collaboration. It will improve safety and surveillance of airport runways. The reliable data through comprehensive field trial at operating runway, considering environment study and airport surveillance for standard reference. Thank you very much, MIC for the funder, KKMM for the support, Hitachi Kokusai Electric, UTM, Malaysia Airport, CAM, JCAP, MCMC, Embassy of Japan, Waseda University, NICT, ENRI, Isma Urus, all the consultants and also contractors, Juruko Fizi, Kamasari, and also Cyberland. I'm sorry, I cannot recall, I cannot mention everyone's name here. It's a really big team, and contributed to the success of this project. I also would like to acknowledge University Technology Malaysia top management for allowing me to speak and to share about this project through this platform. Dato' VC, DVCs, Dean, Dato' Rafiq, Faculty of Engineering Management, Chair School of Electrical Engineering, Prof Wazir and team, my friend here, my boss actually, Dr. Asrul, he's in this hall, Head of Lightweight Communication Research Group, Dr. Azura, now Head of ICOSA Odyssey of NJIT, CES, CES Center, Office of Deputy Vice Chancellor, Academic and International, Office of Deputy Vice Chancellor, Research and Innovation, and of course, my friend at the UTM Corporate Office. All right, can you see the radar? Okay, this is the remarkable photo I taken from Berita Harian. MH604 aircraft carried the first dose of COVID-19 vaccine landed in Kuala Lumpur International Airport 21st February recently. Can you see the radar? You can see the radar tower 25 and 26 in this photo. And of course, everyone are welcome, but you can see from the outside of the airport. If you landed at runway 2, definitely you can see from your left side. All right, to better understand about the system, Secretariat, please show the montage of the system. Thank you very much. Terima kasih. Arigatou gozaimasu.
Five, 4, 3, 2, 1.
We are delighted to have embarked on this G2G collaboration between Japan and Malaysia. Japan has long been a country with great technological advancements, So we are pleased to have this opportunity to learn and adopt new technologies, especially in view of our ongoing Airports 4.0 initiative. The implementation of the Foreign Object Debris Detection System, or FODD, has brought great benefits to Malaysia airports. As an airport operator who, among other things, is responsible in ensuring the highest level of operational safety at the airport, we are keen to embrace technologies that would enhance safety levels and at the same time improve operational efficiency. On behalf of Malaysia Airports, I would like to thank all parties involved in this innovative project, not only to all the various Japanese organizations, but also to University Technology Malaysia, who had contributed the expertise and guidance throughout the project. Thank you very much.
Alhamdulillah. Thank you very much, Prof. Sevia, for enlightening us with the extraordinary journey that you have gone through in order to bring the radio over fiber technology from laboratory to the real practical field through the field trial of linear cell radar over fiber FODD detection system at KLIA. I believe we all are very much inspired now, seeing how you bring your research work to a very much greater height. Okay, now I would like to invite Professor Engineer Dr. Abu Samah bin Muhammad Sutan, who is also the Chairman of Research Alliance in Innovative Engineering, to review the professorial lecture. Over to you, Prof.
Ya, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala asyrafil anbiya wal mursalin. Wa ala alihi wa sahbihi ajma'in. Thank you very much, MC, Professor Engineer, Associate Professor Dr. Nadia, Honorable Chairman of Professorial Inaugural Lecture, Professor Emeritus Datuk Dr. Ahmad Idrus, also my Head of Department, Dean of Faculty at that time, academic colleagues, industry partners, friends, students, ladies and gentlemen, wherever you are, in the Facebook Live resort, of course. And also thank you, Professor Engineer Dr. Sevia, for giving a Professorial Inaugural Lecture today, titled Radio Radar over Fiber Technology from Research to Airport Operation. I think it's very inspirational lecture indeed. What I can say is from lab to the market. And with the involvement of many collaborators, which include the academia, research institution, industries, authorities and regulators. And therefore, I would like also to record my sincere thanks to all parties involved in making this research project collaboration a success. To name it, Ministry of Internal Affairs and Communication, MIC Japan, Ministry of Communication and Multimedia, Malaysia, Malaysia Communication and Multimedia Commission, Malaysia Airport Holding Berhad, Hitachi Kokusai Electrics, Civil Aviation Authority of Malaysia, CAAM, Aisman Urus Senjat Berhad, Waseda University Japan, Electronic Navigation Research Institute ENRI of Japan, and also NICT, National Information and Communication Technology Japan, especially to the President and the Steering Committee of NICT ASEAN EVO, Information Communication Virtual Organization. EVO stand for the Information Communication Virtual Organization, who signed the MOU in 2015 with UTM that I believe has boosted this cooperation. I am honored actually today to be invited by Prof. Sevia as a commentator on her Professorial Inaugural lecture today. And at the same time, I also feel proud of her as a former student of mine once upon a time, way back in 1990s, I think, yeah, when she took an optical communication system course. And then she pursued a final year project, undergraduate project in optical communication engineering under my supervision. If I'm not mistaken, her final year project at that time was related to FSO, which is a free space optics, which studies the effect of atmospheric weather conditions on free space optic, which the transmission media is the free space, whereby she need to design an optical transmitter, atmospheric chamber, as well as the optical detectors at a very short distance, around 1.5 meter, and then to simulated the rain, turbulence, and scintillation effect on line of sight free space optics. And then again, she need to compare with the actual system, whereby you need to build the system between, and then have to put the optical transmitter between optical transmitter and the receiver, or optical transceiver in between of the two blocks at a distance of 100 meters. Therefore, I feel that our speaker today is indeed passionate, and continue to maintain her knowledge in optical communication engineering. This we can see, can be seen from the title of Professional Inaugural Lecture today, and even has been incorporated both, technology, which I would say is RF technology, and as well as the optical technology, which is two different technology here, RF, radio frequency technology, and the optical communication technology. Where RF technology is base system in electronic engineering, and the optical communication is photonics engineering. If I can elaborate a little bit, about the electronics and photonics, if in the electronics engineering means that the movement of the particle that carry information is the electron. But in the photonics engineering, that's why they call it a photonics, optical communications, to be glamour. I think recently we use photonics, meaning that the particles that called photon that carry the information. So with this, with the combination, of this technology, that we call it as ROF, radio over fiber, whereby the light is amplitude modulated by a radio signal and then transmitted over a optical fiber link, that to facilitate the wireless access that makes possible to distribute RF signals from a central base station to remote antenna units, as we've seen from her lecture today. So RF, radio fiber, make it possible to centralize the RF signal processing function in one shared location, in this case a central base station, and then to use the optical fiber, which offers a low signal loss. I would say if working at the third telecommunication window is around 0.3 dB per kilometer losses, which is very low. And to distribute the RF signal to the remote antenna units. So by so doing, remote antenna units are simplified significantly, as they only need to perform optoelectronic conversions and amplification functions. So to bear in mind for the optical communication, when we work together with the RF technology, so we need to convert the signal, from the electric to opticals. But in this case, by having this ROF, we need only once, to the conversion of optical to electrical. So the centralization of RF signal processing also function enables equipment sharing, dynamic allocation of resources, and simplified system operation and maintenance. So of course, the combination of the RF technology and the optical technology or radio over fiber technology should be implemented to transport these millimeter wave signals to remote radar heads via optical fiber network. So the system will provide more advantages, and among them are low attenuation. Okay, it is a well-known fact that the signal transmitted optical fiber attenuate much less than through other media, especially when compared to the wireless medium. So by using optical fiber, the signal will travel further and reducing the need of repeaters. Actually, it is the beauty of optical communication technology, which offer high bandwidth up to terahertz region. When we see in the RF technology, the electromagnetic spectrum is up to 300 gigahertz. But by combining this optical communication, we can go up to terahertz regions in the electromagnetic wave spectrum. And then again, low loss at the telecommunication window, which is now all the operators of the telcos operators, they are working now at the 1550 nanometer wavelength. And then with the low power, low attenuation loss, as well as low power. For the optical fiber, 0.3 dB per kilometer. That means in 1 kilometer, when the signal travel, the losses is only 0.3 dB. When compared to the optical, compared with the coaxial cable, it can cost up to 6 dB per kilometer. So can we imagine with the optical communication system, optical fiber, at the same time, low power means that if the low power with a very, in a milliwatt region, we can transmit for long haul communication, for the long haul might be more than 60 kilometers without repeaters. And again, this fiber optics is non-conductive materials, is very suitable to be used in very compact environment. I would say like runway, aircraft, in the aircraft, which is non-conductive material, that is a glass or polymer, which is raw materials. And the most important is because of non-conductive material, there will be no electromagnetic interference. And also when we see this technology, so we'll see that the low complexity, as I mentioned earlier, that this ROF, we need only one times conversion from the electrical to optical conversion, or optical to electrical conversions. So they will make this ROF make use of the concept of a remote station, and this consists only optical to electrical amplifiers and the antenna. This means that the resource management and the signal generation circuitry of the base station can be moved to a centralized location and shared between several remote stations, thus simplifying the architecture. And of course, lower cost, simpler structure, or of a remote base station means lower cost of infrastructure, lower power consumption by device, and simpler maintenance, all contributed to lowering the overall installation and maintenance cost. And most important is the future proof. By the use, with the use of fiber optics, are designed, to handle gigabit speed, which means they will be able to handle speed offered by the future generations of network. for years to come. As stated at the moment, the system can already demonstrated highly accurate and fast detection, whereby it was able to detect 3 centimeter foreign object debris within the range of 500 meter in 10 seconds by using the millimeter wave radar. This is made possible by the use of radio over fiber. So therefore, with the ROF technology and with the combination of many advantages, a high precision system to detect foreign object debris on runways of the KL International Airport is expected to benefit and ensuring better safety and security as well as efficiency. So by having this foreign object debris detection system in the airport environment, which can injure or damage the airport, personnel and craft and aircraft, for sure will reduce the cost of the global aviation industry, direct and indirectly, including flight delays and runway closures. So as mentioned, the system consists of 90 gigahertz radar supported with high resolution camera to ensure high quality images, as these images will alert the operator about the foreign object existence at the runway. So the system also allows real-time data collection, enabling the airport authorities to identify FOD or foreign object debris on the runway and clear them quickly, which was vital as aircraft takeoff are only minutes apart. So by having the system, for sure, we'll avoid a lot of unwanted accidents on runway caused by foreign object debris. So the system demonstrated highly accurate and fast detection, whereby it was able to detect 3 centimeter foreign object within the range of 500 meter in 10 seconds by using the millimeter wave radio. On top of that, this project research collaboration is Malaysia's first contribution in terms of data and technology to the ITUR, International Telecommunication Union radio communication sector, which means that Prof. Sevia and teams is part of the member in giving the standards, of the in the aircraft industry about the radar system to the International Telecommunication Union for radio communication sector. So UTM in this project led by Prof. Sevia is responsible on the design, development and construction of the system infrastructure, as well as to test and evaluate the system to ensure that the instrument used will achieve the field trial objective to improve the airside operation. So the advantages of the system include its low operational costs, low emission of radio waves, and most importantly, a highly scalable system for busy airports. So other benefits include the reliability that come with a computerized system that reduce the possibility of human error and offers the ability to continuously monitor the runway around the clock, 24/7, without having a delay to delay airport operation to perform routine foreign debris runway checks. So it is indeed an important milestone for the project conducted by Prof. Sevia and team in terms of enhancing foreign object debris detection system that will improve the civilian measures of runway towards strengthening Malaysia's position as a global aviation industry hub. So finally, in the context of the university, the expertise gain is very significant for technological advancement and the talent management in this area, as the demand of foreign object debris detection system for airport runway is increasing due to explosive growth of air traffic. With that, I end my commentary of the Professorial Inaugural Lecture by Professor Engineer Dr. Sevia Mahdaliza Idrus, titled Radar over Fiber Technology, from Research to Airport Operation. Thank you very much. I pass back the mic to and the screen to the MC. Thank you.
Alhamdulillah. Thank you very much, Prof. Abu Samah, for the excellent review. It's very helpful of Prof. Abu Samah to explain the very basic fundamental knowledge of different communication media, such as optics, wireless, radar, coaxial cable, so that viewers from various backgrounds can appreciate the subject of today's lecture, which is ROF, and how it's applied in airport operation. Okay. So now is the time that I would like to open the floor for the feedback and Q&A session.
Tak dengar suara.
Okay. All right. I'll give the first question to Prof. Sevia. Okay, Prof. Sevia, why it is important for academicians, especially lecturers in UTM, to get out of our comfort zone and embrace challenges in commercializing research?
Okay, thank you, my dear friends, MC of the day, Dr. Nadia. Yes, definitely, Doctor. One of our tasks is to solve industry problem with innovative solution. As a lecturer, as a researcher, we should engage with the industry, to understand actual problem, real problem, to understand the issue and craft the research proposal to solve the problem. When the research work are based on the industry, usually, with the experience working in this field, the research work can be realized practically and easily commercialized. Yes, there is a two type of research. We have a fundamental research, we have application research, we have innovative research. We need to do these three types of research because we need to fulfill. Most of our publication can be usually is the outcome from the fundamental research, but to show the real contribution to the society and also industry, we need to work towards another level, which is innovative research. Hopefully, all of my friends here, my academic friends, all the lecturer, go to the industry, work together with your student with the industry, and then start working on the real world problem. Definitely, from working on that level, you can come up with a new theory, new contribution to the knowledge, to the body of knowledge. And of course, through that exercise, I believe, we as researcher, we need to maintain our stamina. Of course, in any way, we need to maintain our stamina. In research, we need to maintain our stamina. How to do that? We need to keep learning, searching new ideas, and definitely we can embrace a new technology, and contribute back to the society. Inshallah, I hope I can answer your question, MC.
Inshallah, thank you very much. I hope I can up myself to the challenge, inshallah. Okay, I'm informed that there's a special appearance from very key partner from Hitachi, where Mr. Nobuhiko Shibagaki-san, a senior engineer from Hitachi Kokusai Electric, will share what he thought about this project and also this lecture, to our FB viewers. Okay, Mr. Shibagaki, how are you?
How are you? Thank you, Dr. Nadia.
Yeah, I'm fine, thank you. Are you in
Hi,
Japan now or
Shibagaki.
in Malaysia?
Okay, can I start?
Okay, yeah, you can give your feedbacks.
Okay, on behalf of Hitachi Kokusai Electric's millimeter wave team, I'd like to congratulate Professor Sevia on her inaugural lecture today. We are currently working with Airport Malaysia and UTM to evaluate and commercialize the runway falling object debris detection system, FODS. I have been working with her team for several years now and have always benefited from her energy and academic insights. The outcome of these activities are also important for contributing to international standardization bodies such as ITUR and ICAO. We are participating in the drafting group of ITUR Working Party 5B1 on FODS issue as a delegate of each country from 2019. We have also collaborated with ICAO to exhibit our technology at their annual directors meeting also. Last week, we had a successful progress meeting event with guests from MHB, UTM, CHAM, KKMM, MC, and the Embassy of Japan in Malaysia, as well as online guests from Ministry of Internal Affairs and Communications and Civil Aviation Bureau in Japan. We'd like to thank Professor Sevia and her team for their effort. We look forward to further strengthening our cooperative relationship to build the safety runway in the world, starting from Malaysia KLIA. Congratulations to Professor Sevia. Terima kasih.
Arigatou gozaimasu, Shibayaki.
Thank you.
Okay, thank you very much, Shibagaki-san, for the feedback. All right, so now, do you want to comment anything on the feedback, Prof. Sevia, or should?
I really numb about the compliment by the Mr. Shibaraki, especially Japan team towards this project for their trusted and also support. And we really glad that we've been informed the project will be continued. Hopefully many more research and also academic insight can be contribute towards this project. Thank you very much, Mr. Shibaraki, with the hustle of your time to come to Malaysia during this pandemic situation. And hopefully we can work together and to enable more in this research area. Thank you.
Thank you.
Okay, thank you very much to both Prof. Sevia and Shibagaki-san. Okay, next we move to the Q&A session from FB. Okay. First question is from Dr. Noriza Haji Rizwan. Thank you very much for the very inspiring, interesting, detailed, and insightful success sharing. I have a question. After any of the 54 types the object has been spotted, does FODS can differentiate the type of object or the type of materials immediately? Okay, so this is first question. And then what is the algorithm of the analysis? Second question from Dr. Noriza Haji Rizwan.
Okay, thank you, Chairman. Can I answer now?
Yes, sure.
All right. Thank you very much, Dr. Noriza. Currently, the FODS radar have ability to detect the existence of FOD, as small as 1 cm's asphalt debris. And then the camera will capture the FOD, push the data to the apps to notify the site staff for their further action. Through the capability of HDC, high definition camera image, the site team can determine the type of FOD. It is not necessary to determine the type of material at this moment, but it is good idea for further study on improving the artificial intelligence of the system. It is part of our research work. The future works will focus on the ability of the system to monitor the runway surface condition, such as water ponding and also the pothole. And thank you very much. All right. Hopefully I answer your question. Thank you, MC.
Okay, thanks, Prof. Sevia, for the answer. Next question is from Dr. Ramesh Zaidi Rozan. Okay, salam dear Prof. Sevia. May I get your comments on how feasible is the of FODDS if the radar is to be attached on a moving platform such as a car, lorry, or even a small vehicle such as motorcycle? Thanks. Okay, Prof.
All right.
Can you
Okay.
answer? Yeah.
All right. Thank you. Yes, there is a moving FOD detection system. Yeah? It can be attached in the moving platform. Yeah? One of the experiment conducted now, I think in Sendai Airport, yeah, by our team. Yeah? Recently, we put the radar at the above of the, I think a bus. Yeah? It can be a car or lorry and so on, yeah, to detect the FOD. Yeah? But however, for the moving platform of the radar, there is a drawback a bit in terms of system performance. But to ensure the optimum performance of the system, fixed location are needed because we have to ensure the system are able to inform the site very fast and to locate the FOD in the exact location within 10 seconds. Because we cannot avoid to close the runway and definitely, if you put in the moving platform such a car, or lorry or something for the runway, it can be materialized only when we want to detect FOD during the runway closure. For example, during after the accident in the runway, but definitely for the practical active runway, we need to have a fixed platform. Inshallah, Doctor, it's a really good question. The team now working towards that. For embarking a new venture for the mobile FODDS system. Thank you.
Okay, thank you very much, Prof. Okay, this is not a question from FB, it's just from MC. Okay, what's the prospect of having this FODDS technology in other airports in the other countries?
Okay, thank you, Dr. Nada. It's a very hard question. I think Mr. Shibagaki should answer the question, but however, allow me to share with you. For everyone and for the information, KLIA International Airport is the first airport have this high-end facility for the runway. We are in the field trial process. Once the certification or the evaluation are completed, definitely this is a cost-effective solution for the FOD detection and also airport safety, runway safety surveillance. And we did have invitation from many airports around the globe to know about this system. And inshallah, Hitachi Kokusai are ready for the commercialize of the system to other airport in Malaysia or other countries.
Inshallah.
And I think I can share with you next airport to be installed this system after KLIA is Haneda.
Okay,
Japan,
mashallah.
2023, maybe something
So
like that.
we can see the potential of this technology is growing, and we can see more, research, very interesting findings from you in future, Prof. Inshallah. Okay.
Thank you.
So with that last question, finally we have reached to the end of today's program. Huge congratulations to Prof. Sevia for her success, and thanks for the wonderful lecture. I also want to thank our chairman and reviewer, Prof. Emeritus Datuk Dr. Ahmad Darus and Prof. Engineer Dr. Abu Sama. And also much appreciation to Prof. Datuk Dr. IR Muhammad Rafiq bin Abdul Qadir, Dean of Faculty of Engineering, to the organizer and committee who have worked hard to realize this event. And not forgotten, thank you also to all the viewers for staying tuned with us within these nearly 2 hours. See you in another lecture series by UTM. So before we leave, let's recite Tasbih Kifarah and Surah Al-As as we seek for Allah's mercy and forgiveness for our mistakes and sins. Subhanakallahumma wa bihamdik asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wal 'asri innal insana lafi khusr illa allazina amanu wa amilus solihati wa tawassaw bil haqqi wa tawassaw bis sabr. Okay, assalamualaikum and have a great day. Bye everyone.
Thank you. Alhamdulillah.